Assalamu alaikum everyone. I'm Rahila Umer. I'm a faculty member in FICT, Department of Computer Science. Currently, I'm doing PhD at Massey University, New Zealand. I welcome all of you to my talk and appreciate your patience and time. My topic of presentation is a learning analytics approach using online weekly student engagement data to make predictions on students' performance. So, higher education institutes are facing challenges due to low course enrollment and further low course completion rates. The issue of low dropout rate is fast becoming a priority, and it is because of becoming a serious threat to universities' long-term financial security. Therefore, universities are seeking for strategies to improve students' retention rate. Early detection and timely interventions for at-risk students have been found helpful in improving students' retention. Due to extensive use of technologies in the education, there is a large amount of students' data available, and this has provided us with opportunities to address the challenges associated with low retention rate. Learning analytics is an emerging research area in the education domain that makes use of such data and uncover patterns that can help to understand the student learning process. Then they analyze their behavior using the data and make predictions on students' performance. There are different ways where higher education institutes are making use of LA. Some of these examples are student behavior modeling, where we analyze students' behavior and correlate it with the academic performance. Or prediction performance is the most exciting subfield where students' performance is predicted during the course or the degree program. Other examples include recommendation of resources, reporting feedback, or self-reflection and self-awareness. Learning analytics is widely used in higher institutes, and it has shown great impact on improving students' performance. So this slide shows different logos of learning analytics tools that are available in market or are being used by institutes. Now, after giving some details of learning analytics and its importance, we will move to the research problem that we are addressing in this talk. So here's the main problem that we are discussing. What we have students data, we got their demographic data, that is definitely given in the start of the semester, and then we have assignments like assignment 1, 2, 3, and we have their engagement data. That's the data when they're interacting with the learning management system, and the goal is to identify students who are at risk of failing the course as early as possible. So this is the end of the final exam, and we want to find those struggling students before the mid of the semester so that timely interventions can be made to help those students. So data for this study is obtained from a course, Introductory University Mathematics. It was offered in 2015 by an Australian tertiary education provider. This course has been designed to improve students' mathematical concepts and skills. The selection of the course is due to the high failure rates and the large number of student enrollments. Total number of students enrolled in the current course are 99. There are two types of data used in the study. One was student assignment score, and second was virtual learning environment engagement data. The engagement data represents student sections like viewing course modules, reading forum posts, creating posts, viewing and submission of assignments, among others. So the VLE data is extracted from Moodle. It's a type of learning management system, and the activities are stored in a built-in log system, and those activities are aggregated and seen in throughout the semester, which were divided into weekly basis. So four machine learning methods were used: naive Bayes, random forest, logistic regression, and k-nearest neighbor. And two different classes were to classified. One was those students who were at risk of failing the course, and the second one, those students who are not at risk of failing the course. For evaluation we used accuracy and FN because we were facing the imbalanced data set. That's why we preferred the FN measure. And for experiments we used Python module scikit-learn, the machine learning library. These graphs show the experiment results. So the experiment prediction was performed using these four machine learning methods, and we divided our dataset into weeks. We considered even the activities which is before term, even the semester starts before. We considered those activities as well, and then there is this final exam. So like I said that we used two things. One was the engagement data and the assignment scores. So the selected course has 5 assignments: assignment 1, 2, 3, 4, 5, and online test. These vertical bars show the deadlines for the assignments. So for example, assignment 1 was due on week 2, and assignment 2 was due on week 4. So we can see there is a steep growth of the accuracy and FN as the time passes, the accuracy of the data improves. When assessment score is not available, the first assignment scores will be available after week 2. Before this time period, we see the prediction is being done only based on the prediction VLE data, which shows that VLE data itself has this discriminating power. But once after week 2, when the assignment scores are available, the prediction accuracy improves more than the VLE data. Here we can see the accuracy is being improved, which shows that both assignment scores and the VLE data have discriminating power. So the idea was to predict as early as possible, and the maximum FN score that we can achieve by random forest is 70%, and which is achieved after week 2, and which further improves as we get more assignment scores in the data. So the results show that VLE data alone has also discriminating power. In order to further see the engagement data, the importance of engagement data, we divided the class into different groups based on their final grade. For example, students who got A grade, B, C, or D, or do not continue. So we wanted to see the different behavior of these students based on their activity, how engaged those students are. So again, we divided the data set in 16 weeks and also considered the activities before term and after term. So these bars in the figure show the average of all students, average of their activities. So this is the all students average, whereas these lines show the different average grades of different groups. For example, this blue line shows the students who got A grade, and it shows that these are the most active students throughout the semester. And the second most engaged group are the students who got B grade or the C grade. And if you see the students who do not continue, we can see their activity is below the average, or it is just almost not continue. It shows that even if we don't have the assessment scores available, but VLE data, if it is rich, can help us to predict the students who are at risk after week 1 with accuracy of 70%. But the success model of the prediction is when it's made as early as possible during the semester so that timely interventions can be made for the students. I conclude my talk with some important results. In this paper, we conducted comparative analysis of predictive models. We used 4 machine learning methods and we predicted the final outcome of the course and predict the students who are at the risk of failing the course. Prediction was done on weekly basis using VLE engagement data and assignment scores. The results show the assignment scores are more discriminating than VLA. However, even using just VLE data, prediction accuracy reached up to 70% after week 1. These results show promising, however, the results cannot be generalized. Prediction accuracy depends on the data that reflects the behavior of students, which is only possible for the courses where students are given more opportunities to interact and engage themselves in the learning activities. And the prediction accuracy depends on the data, and the data quality and quantity both matter. So generally, the greater the range of the data sources and the more options tested, the more valid will be the resulting models. Thank you all for your patience. If you have any questions, I can be contacted through these emails. Thank you.